So I just want to go a little more in depth about this mass balance equation I have of where it was QB is equal to Q over S CB naught minus Q over S CB. And then I had a graph right here where this is QB and this is CB. So let's say our initial concentration is right here. This is CB naught. As CB decreases, the Q increases. So this is the amount that's leaving with the adsorbent. And this is the amount that's still in the fluid. So we want this to be very small so this can be very large. That's all this equation is showing. And then I showed the KCB is equal to QB. This is also a linear line. So K is a fixed, for this part, it's fixed and it's something that you can look up or you'll be able to given to figure out what it actually is. But most likely you'll be given this and you have to calculate it. So then that gives you, as you increase B, more is going to stick to the absorbent. So when these two lines meet together, that's where your mass balance of what's going into the system and what your equilibrium information makes. So this is the only place where you can have a system where it's in equilibrium, is right there, where this is your mass balance equation, this is your equilibrium information. So that's all those two equations really mean. So next I want to talk about what happens if you can no longer assume that you have open sites, because this is only for a lot of open sites. Well, let's assume that those sites start filling up. What does it look like? Well, it looks something like this. Or initially it's straight, but then it goes like that. It levels off and there comes a point where all the sites fill up. And that is a Langmuir isotherm. And how we get that is we say that we go back to our original equation where we have KEQ is equal to QB all over CB times open sites. And we actually can give an equation for this of saying that the total number of sites are the open sites are equal to the total open sites minus QB. And we'll actually give this a new definition. We'll say new variable, and we'll say that's S tot or S total. So then that becomes S total minus QB. And we're going to plug that into this. And that gives us KEQ is equal to QB over CB S tot minus QB. Solve this equation for QB, we get QB is equal to KEQ the total open sites before anything attaches, times CB, all over 1 plus KEQ times CB. And this is the Langmuir isotherm. Another isotherm is QB is equal to C1 over N. And this is the Frodrink isotherm. You can only get this from experiment. And that looks something like this. It's never linear and it never flattens out. It's always got a curve to it. So that's the different types. And to go in the next video, I'll go a little more in depth into this equation.